The section's on 8.1 sequences. So sequences actually was addressed in Algebra 2. So let's go over some of the patterns or the formulas that we need for this. One of the sequences that we need is the arithmetic sequence. So if you remember in the arithmetic sequence, there was two parts that we need. We also need is recursive sequence right there. And so recursive means that I need a first number a1, and then also on the an, which is the n minus 1 plus d. D is going to be the pattern. Either you're adding or subtracting by some number right there. Okay? The other one is called the explicit, and we like the explicit because this one right here, I can actually jump around and figure out what the next term is. But the recursive right here, we need the previous number, if you remember from Algebra 2. So if you have like the first number, then you need to figure out what the second number is, third number, etc. Where this one explicit, I can figure out what the first number is, the fifth number, and then jump all the way out to the 100th number. Okay? Then we have is also the geometric sequence. So the geometric sequence also has similar right here. We have the recursive, so which means the first number right here, and also the formula for the geometric sequence is the an minus 1 times r. R is the pattern. So in geometric, we're either going to add, or multiply or divide. So that's going to be a fraction right there. It's either going to be a whole number or a fraction for the pattern right there. And then for the explicit, same thing. I could jump around in the geometric sequence right there. We like that. We still have is the R right there, which is the same thing as this R right here. It's the pattern. But I also have is A1. And A1 is always the first number. So which is mentioned in this right here, the recursive. Okay? So using the four formulas right here, that's what we're going to use to figure out the problems today. So let's do example 1. So example 1 is an explicit formula. We're asked to find what is the first term, the second term, the third term, and then also the 100th term using this formula right here. So the formula is an is equal to negative 1 to the nth power, right, divided by n squared plus 1. So if I substitute in 1 into here, that gives me a1, which means that's the first term. And then I would have to substitute 1 into my other ends, which is here and also here. So that's going to give us something like this, and that gives us negative half. If I'm looking for the second term, I'm going to substitute 2 into each of the ends right there, right? And that's going to give us 1 over 5. If I substitute 3 to figure out what the third term is, so that's going to give us negative 1 over 10. So obviously now I can jump to the 100th term because all I have to do is substitute 100 into all my ends, right? And that's going to give us something like this, 1 over 10,001. Okay? Now let's talk about the recursive. Now the recursive right here, we're going to jump to first number, the second, third terms, right? And then also the 8th number right here. Okay, so here's the thing. I need to start off with the formula, which is a1, or in this case b1, is equal to 4. And then they also gave us a formula, so bn is equal to n minus 1 plus or minus something, right? In this case, it's plus 2. Notice also recursive is always at n minus 1 because you're always going to use the previous number. So if I'm asked to find the first three terms, I already have term number 1 right there because b1 is equal to 4. So I'm actually going to look for the second term. So second term says I'm going to go ahead and put in 2 for the n. So it's going to be b2, and this is 2 minus 1, which is actually 1. So it's really b1 number is what I need, and we're going to add a 2. So b1 number is 4, so that's where we get this. 4 plus 2 gives us 6. Now I'm looking for the third term, right? Because I need 3 terms here. So I have is b3, right? 3 minus 1 is 2, so I really need is b2 term, which we found is 6. And we're going to add to 2, that's going to give us 8 right there. Okay? Now, we're also asked to find the 8th term. That means I would have to find what the 4th, 5th, 6th, 7th number is, right, to get to the 8th. I can't jump from 3 to 8 in this case on the recursive. So here we go, dot, 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 right? And then we do the 8th term. So the 8th term right here, we found out the 7th term is actually 16. And then so 16 added by 2 gives us 18 right there. Okay? So that's the recursive, just showing you how that works. So now let's do the arithmetic sequence part of it. So we're going to be asked to do 4 parts. One of them is going to ask to find us the common difference or the pattern. So it's either going to be adding or subtracting as the pattern. We're also going to be asked to find the 9th term in this case. Okay? We're also going to be asked to find the recursive formula in the nth term, meaning just leave it as an n as the equation, general equation, because I don't know if I'm looking for the 5th term or the nth term, which is like a 100th term, right? So we're just going to leave it as some kind of n. And then same thing with the explicit, we're going to leave it as some kind of n term out there. Okay? So example 3 says I have is -5, -2, 1, 4, 7, etc. So what is the pattern of this? Well, I'm going to add or subtract something right here. So I think right here is a little obvious right here that maybe I'm going to add by 3, right? 1 plus 3 is 4. If I add 3 to this 4, will that give me 7? Yes. Okay, now let's check it on the other problems or the other numbers as well. So negative 5 plus 3, that should give us negative 2, right? Negative 2 plus 3 should give us positive 1 as well. So it should work for all right here. If it only works for 1 or 2, that is not the pattern for this. So in this case, we said 3 is the pattern right there. Okay? Now, part B is asking us to find the 9th term. So the arithmetic sequence, remember the explicit, because I can jump from the 9th term here. I'm going to go ahead and put 9 into my n right here. So I'm going to also put 9 in here, because that n is the same representative. My A1 right here, I know is my first number, which is negative 5 in this case, right? And then D right here is the pattern, which we found is to be 3 right here. Okay? So if I put it in correctly, all my substitution right there, and just calculate, I should get 19 as my final answer. Okay, now let's do part C. So part C is asking us to find the recursive formula. So if you remember the recursive for the arithmetic sequence is this formula right here. And so we said on the recursive, we always want the first number, right? So A1 should equal to negative 5, so that's going to be A1 right here. Then the next part is just a general equation. So I'm going to leave my AN and also leave my n minus 1, because whatever that number for the n is, remember we substitute into this n as well. So we want to keep that as a general equation, because I don't know what term I'm looking for. So leave that. But the D, I do know that's going to be the pattern that we found up there. So that's the 3 right there. So that looks something like this. So that's the general equation I need for the recursive. And this right here together will give me the 3rd, 4th, etc. terms. Okay? Now I'm asked to find the explicit formula. The nth term, same thing. So the explicit formula for the arithmetic sequence is this right here. So again, I'm going to leave the n right here because I don't know what term I'm finding. So we'll leave the n right here. We'll leave the n as well for this one because it's the same n right there. And I know what A1 is, right? Because we found out A1 was negative 5. And I also know what D is because D is the pattern, which is 3. So we're going to do some substitution right there. And then I'm just going to go ahead and distribute combined like terms so I have a formula that I can work with. So this is the formula right here that if I'm asked to find, let's say, the 5th term, I just put in 5 into here, 5 into here, and that should give us the 5th answer right there, or the 5th term answer. Okay? So let's go and do the geometric sequence now. Now the geometric sequence, we're doing similar things. We're going to find the ratio or the pattern, right? It's either going to be a whole number or a fraction. We're also going to be asked to find the 10th number. We're also going to be asked to find the recursive formula in the nth term, like the previous problem. And we're also going to be found the explicit formula doing the nth term as well. Okay? So here's the pattern. It's 1, negative 2, 4, negative 8, and positive 16. So what is the pattern that I either multiply or divide by to get to the next number? Well, let's see. I usually just go with a number and just divide it out right there just to see what that looks like. So in this case, if I do 4 divided by negative 2, that gives me about negative 2. Okay? So negative 2 is what I'm saying is the pattern. Notice it's a whole number, so that means I would multiply. So if I multiply 1 times negative 2, that gives me negative 2. That looks good so far. Negative 2 times negative 2 gives me positive 4, so that looks good. 4 times negative 2 gives me negative 8. Negative 8 times negative 2 gives us positive 16. So that works. Okay? Now if you divide it out and it was a fraction right here, right, then you can still multiply by the fraction right there, or you can divide by that fraction denominator. All right, let's do part B, which is asking us to find the 10th term. So the the geometric explicit, that's the one we could jump, right? We're going to find out what the 10th number is. So the n right there represents 10. This n up here on the exponent represents 10. I know what r is, which is the pattern right here. We found out it was negative 2. And I also know what a1 is, which is the first number in this case right here. Okay? So if we do all the substitution, that's what it looks like right there. And I just put in the calculator, get negative 512. Okay, now let's do the recursive formula in the nth term. So here's the recursive formula for the geometric sequence. So I just leave my n's right there like we did in the previous one on the arithmetic sequence. I know what r is, which is the pattern right here, so that's what I'm going to use. But don't forget, you need the first number, right? So we always start off with the first number as 1 in this case because the first number is 1 right here. And then the general equation is negative 2, right, because that's the pattern, times an minus 1. Okay? So you need both of these right here for recursive. Remember, recursive comes in 2 parts. It doesn't come in 1. Now let's do part D, which is asking us to find the